Now, when we're looking here at our equilibrium constant, here's our first example, but I wanted to first talk a little bit about the, all right, where'd that go? Want it up there. Right here, our equation for the equilibrium constant. Now, if you saw on the video that it said that at times you will see this as K with the subscript EQ, while at other times you'll see it with the subscript C. So just be aware that you can see it using either way. But the main thing, the equilibrium constant equation comes from the balanced chemical equation. So when I'm calculating the equilibrium constant, I take the concentration of the products and I multiply those by the specific coefficients that are in front of those. So as I am looking at this, very first one here, this bracket C right there, that means the concentration of whatever product C is. And we take that to the C power. So whatever coefficient is in front of it is that little c. So let's just pretend that that was water. And it said, for this part, it was 2H2O. So we would take the concentration of water squared. So that's how we read it. Now, how are concentrations given to us usually? By what? You know? Molarity. Okay, capital M, right? When we're working in our labs, we have capital M usually as our concentrations. Now, the final thing I wanted you to just to make sure that we got this from our notes, that if the equilibrium constant is greater than 1, the products are favored at equilibrium. If the equilibrium constant is less than 1, then the reactants are favored at equilibrium. So when we go back to our first problem here, it says the equilibrium reaction that takes place between sulfur dioxide and oxygen to produce sulfur trioxide is given below. The following equilibrium constants were measured. So I have the concentrations of each one of those at equilibrium. So it tells me calculate the equilibrium constant for this reaction. Well, I know that my equilibrium constant is going to be the concentration of my products. In this one, I only have one product. Sulfur trioxide is my only product. And I divide that by the concentration of my reactants. So I have SO2, and there are 2 of those, so I square that. And then I multiply that by my concentration of oxygen. And there's only one of those, so that'll be to the 1 power. Now, I've got my equation set up. All I have to do is put in my actual concentrations. Well, at equilibrium, what was my concentration for sulfur trioxide? It says right here, 1.1, right? So I put in 1.1. Sulfur dioxide was 0.9. Oxygen was 0.35. So now all I have to do is my math with this. So I take 1.1 squared, and I divide that by 0.9 squared times 0.35. And it gives me a value of Kc to be 4.2. So my value for the Kc is going to be 4.268. And if I would go back, it looks to me like I have 2 sig figs. So my equilibrium constant equals 4.3. If I am setting up my equilibrium constant equation, I know Kc is equal to the concentration of my products over the concentration of my reactants. Both of those have a 1 as a coefficient in my balanced chemical equation. So once again, I've got set up my expression. All I need to do now is put my values into that expression. So my concentration of hydroiodic acid is 0.315 molar. My concentration of iodine, well, this is hydrogen, I guess I used first, is 0.200 molar. My iodine is 0.200 molar. So when I put these together, 0.315 squared, and I divide by that 0.2 times 0.2, and that gives me a value of 2 with 3 sig figs, 2.48. Now, when I showed you this one, folks, I'm putting it up here because we look at this, and our first one, I didn't put a label on. This one I have not labeled yet. All right? But if we would look at the top one, our label would be m squared, right? If we would look at the bottom one, what would our label be? M squared. So for this particular one, it wouldn't have a label. Now, this is getting into the different coefficients. I'm not so concerned about you knowing the labels with these because it could change. So I can't say, well, your equilibrium constant is never going to have a label, because that's not a true statement. But I don't want you right now to get caught up into what the label of equilibrium constant is. What I want you to be able to tell me is, okay, here's my equilibrium expression. Here's the concentrations. Can I calculate my equilibrium constant? Yes, I can. And then after I've calculated it, can I tell you whether that the products are favored or that the reactants are favored? Okay? That is what I am looking for, ladies and gentlemen. Now, what I would like you to do is work this final one. Now, looking at this one, just to give you a hint, okay, I'll let you copy it down first and we'll talk about it. Now, what I'm going to do, folks, is I'm just going to give you a little bitty hint, and then I'm going to let you work this on your own. All right? Remember that our concentrations need to be in molarities. On this particular question, you are given the amount of moles per 2 liters. So in order to get my molarity, if you remember, our molarity is our number of moles of the solute divided by the liters of the solution. So in order to determine the molarity of each one, I'm going to, for instance, for the PCl5, I'm going to take 0.2 moles and divide it by how many liters? 2 liters. So my molarity is going to be 0.100 molar. So you have to figure out the molarities first before you can plug them into your equilibrium constant reaction. Okay? What I want you to do is I want you to work this problem, and we will start tomorrow by me looking at what your answers are for this particular problem. And I want you to tell me whether the products or the reactants are favored in this reaction. Okay? So I guess that's your only homework right now.